Hello friends, today we are going to understand what is the architecture behind famous content website Netflix. Netflix is a website where we are hosting a tons of content, movies, series and lots of videos. While designing the architecture for Netflix, what are the major things which we need to consider in our mind? Apart from normal website jobs like login, my account, billing, etc., the three important things which we need to understand and consider in our design is how to do super fast streaming, how to make video or content compatible to all devices. There are different devices like mobile, laptop, tab, and how to give end user a personalized touch. Let's take one step at a time. First of all, how to do super fast streaming. For this, Netflix is using OpenConnect. OpenConnect is nothing but a CDN where all the content is recorded or hosted and everything is streamed from OpenConnect. It is Netflix's own CDN. How to make video or content compatible to all devices. Before moving to this thing, basically we need to understand how we are uploading a new video on Netflix. Whenever a new video came, after validation and transcoding, basically the video is splitted into small chunks like 10 unit video, maybe 10 GB video, 10 MB video is splitted into small chunks and then stored in a queue. We are using Kafka queue here, from where a multi-part uploader is working concurrently and just uploaded the small chunks to the destination. And at the destination, all the small chunks from the offset and the identifier, it just merged to build the complete unit. And this is how the big video is uploaded successfully, and via concurrency it uploaded quickly also to the destination. So now jumping to the overall complex architecture of Netflix. Looks like a complex but not exactly if we'll go one by one. As we already discussed three major problem statements which I have highlighted here: how to do super fast streaming, how to make video and content compatible to all devices, and how to give end user a personalized touch. This we will take it later. So let's start from first step, when a user want to see anything on his mobile. So as I told, when a user click on play button, the streaming starts from OpenConnect. But apart from the play video, like the services of login, rendering of dashboard, billing services, so it hits to load balancer, and via load balancer an API gateway. Netflix uses Zool as its API gateway, which is kind of a combination of proxy server plus few filters. So basically inbound filter, outbound filter, and endpoint filter. The request goes like end user to load balancer to proxy server, passes to inbound filter. And inbound filter, the request is filtered on the basis of like if we have to shard the traffic, if we have to do filtration before execution on the request, then it goes to endpoint filter, and endpoint filter will propagate the request further towards the microservices. But yes, before moving forward, let's see what exactly the use case of this API gateway and what are the benefits which we can get from API gateway. So with the use of this API gateway, what all the features we can do: traffic sharding via the endpoint filter, load testing, if we have to test a new service, or we have to filter a bad response. All this thing can be done via API gateway. So request filtered from this gateway to a fault tolerance application. So Hystrix is in use in Netflix for fault tolerance. It's nothing but if we have to implement timeouts on the services which are taking much time, or reject the request if our thread pool is full, means our capacity is completely occupied and we are not able to take any further request. Circuit breaker is nothing but the similar kind of an execution, or probably we have to send a default response as a fallback response if there is a dependent services. All these topics will be covered in detail in the other videos where we will focus on what exactly fault tolerance application in detail, and similarly for API gateway. Here we have to focus to cover the architecture of Netflix. So let's move from this fault tolerance to the microservice. So basically on this layer, Netflix implemented one more cache layer on top of their databases. So Netflix has MySQL and Cassandra. For all relational data, they use MySQL, like the details of order, transaction, and user. And in Cassandra, they have the unstructured data, like at which point of time user left while looking a particular video, the offset of that video, viewing history, all that data, all the events are stored in Cassandra. But to cut down the hop of this Cassandra or MySQL, they have EV cache. EV cache is nothing but a cache cluster on Memcached. It's also invented by Netflix and it's their in-house development. Here you can see two kind of microservices are there. There are n number of microservices like order service, billing service, transaction service, user service. But what is critical microservice? So basically when we will go through in details of microservice architecture, I'll explain in depth. But just to cover the high level difference, if we need some microservices which we can't afford to be down, so we'll remove the dependency on those microservices, so those are less dependent. And such kind of microservices, like an example, I have to serve the data for dashboard. So when user came to Netflix, login, dashboard, these are the APIs endpoints basically, which we can't afford to go down at any cost. So for that, we are just trying to make those services less dependent. So those services are under the bucket of critical microservices. These microservices are connected with the database layer. And here the uploader microservice, as I already explained, as we already seen, how a new video uploaded on Netflix. So this is the flow which we have discussed, so I am skipping it right now. And this is the most important part. All the every event which is coming, a data, is processed by Apache Chukawa, which is nothing but an application built on Hadoop to manage the data. Apache Chukawa passes the data to Hadoop and also stored in the Kafka queue, from where the data is propagated to Elasticsearch plus Spark. Elasticsearch is used for full text search. Let's say user want to search a particular movie, then this flow will be for that particular request. And Spark for all the recommendations and data analytics. So this is the most important thing to give the personalized touch. Spark is used for movie recommendation system, like the interaction of the user. What is the other user's taste? metadata of a movie like the title, actor, or director. Like if some actor is famous and if I have seen movie of that particular actor, then Netflix can relate it and recommend me the other movies of that actor. Plus time of the day, device, all these things are content based filtering. Another one is collaborative filtering. So in Spark, basically if a user A liked a movie which is fiction movie and post that A has seen a movie B, if some other user will see movie A, Netflix can show him the movie B in the recommended section. That we can call collaborative filtering. So, if one more example, like if you have started to see a web series, part 1 is already viewed, then it's obvious that most of the users will go to part 2. So, Netflix already cached all those content which is recommended for that particular user in the region of that user in OpenConnect to get the faster access for all the recommended or most probable videos for a particular user. So, this is how Netflix covers the fast streaming, and it covers the compatibility with all the devices and also gives the personalized touch. Thank you. Hope you like the video. Please subscribe for the other videos where I'll going to explain each and every component in detail. Thank you.